Welcome to Future Foodcast. I'm Pam Leinmiller, your host. I love that we have the opportunity today to talk about applications for technology and innovation to really leverage our ability to increase productivity and all the activities that happen in agriculture. We have with us today the Chief Business Officer and Head of Agronomy for Arable, Oz Ben David. Welcome to the podcast, Oz.
Thank you very much, Pam. How are you doing?
I am doing great and so excited to dive into some of the innovation, just the cutting edge technology that your company is implementing out in the agricultural world. First of all, tell us about Arable and what you do.
So we develop a very unique technology. It's an IoT device that sitting in the field and collecting information from the plants, the environment, and the soil. And in general, just to think about an IoT device that needs to be in the field, it's a very big challenge, right? Because we have to make sure that it is resistant to different weather conditions and different crazy things that can happen in the field. So to develop an IoT device from scratch is a very big challenge, but I'm happy to say that our company was able to develop a very good product. It's called the Mark. It's the Mark III. The meaning is that we had two versions before the Mark III, and the reason that we have the Mark III that those two versions was not good enough for us. So we wanted to improve those the quality of the hardware and the device.
Wow, that's so exciting. Let's take a minute to explain. I think most of our audience is familiar with IoT or Internet of Things, but the whole purpose, like this device, you talked about the different things it tracks, and we'll talk about each one of those. And I know you've got a device to show us in just a minute, but the sensors, like you're able to calculate or measure the amount of rainwater, sense the temperature. You've got sensors in this device, right? To be able to give us all these analytics from the field.
Yes, the idea is to develop a device that can include multiple sensors and to collect all the information that's relevant for plants. So it's a very unique device that developed specifically for farming and agriculture.
Yeah.
And also the idea behind this device was to develop a device that is not required any maintenance. We can deploy it anywhere in the globe, and today we have deployed our devices in more than 55 different countries around the globe. So we are a global company. We have a global team that's supporting global companies, and it's a very big challenge, right? So, but the idea is that it has to be very easy to deploy, because if the deployment is very messy and complicated, it's very complicated to run a global operation like this. And to maintain and to deploy the devices, it has to be very easy. So our device, one of the biggest strengths we have, it's that it's very easy to deploy. So it's only 5 minutes deployment. You just need to push on a button and that's it. The technology can start to work for you and not the opposite. This is one big challenge that we overcome by designing the right product. The second one is the maintenance part. The maintenance is that if you have a device in the middle of nowhere right now, in Argentina or Ukraine or Brazil, and you want to measure rainfall. Rainfall is it's a key factor for decision making in farming, in agriculture, specifically for irrigation. And if you want to measure rain, until now, basically almost all the different instruments that are available in the market using a tipping bucket. A tipping bucket, it is a bucket, right? And a bucket in the field, it is a problem because it's a very good place for anything to just be there, right? If it's a frog or any type of a bug, or if it's a debris from plants. So it's very sensitive, and usually you cannot get a very consistent data. So we want to make sure that we have this capability to measure rain, because rain is one of the key measurements that we are collecting without any maintenance, but also with a very good level of trust that this data is accurate and I can trust that this data will continue to be collected moving forward. So what that we are doing, we're using basically we are using it's called acoustic distrometer, and we are listening to the rain. So we are converting the sound to a rainfall amount. So,
Really? That is genius. I don't even know how you do that.
so, if for example, our brain is working exactly the same. So if we are talking right now, so there are a voice wave that can move the air, and the air is hitting your eardrum,
Yeah,
and your brain translating those noises to words.
yeah,
So basically, we are doing the same. Our brain is much more sophisticated than our device. We have to be very, very modest about it,
yeah,
but it's almost the same. So we are listening to the sound. We have an AI algorithm. This is the brain in this case, our metaphor.
right.
And we train this algorithm to be able to identify what type of rain is it, if it's a monsoon or a different type of rain,
Mhm.
and what is the amount. And this allows us, first of all, to remove or to move the tipping bucket challenge. So we don't have a tipping bucket in the field. We can update the model in real time from online, so online update if necessary. And also it's allow us to build a product that don't require any maintenance, because the biggest maintenance requirement is for the tipping bucket. You have to clean it, you have to calibrate it. In our case, you just need to push on a button, deploy it in the field, and that's it. You can forget about it, and the system will start to collect information for you. And what we are doing with this information, we can talk in a second.
Yeah, let's just pause and understand 5 minutes to deploy your device,
Yes.
which is unheard of, like quote unquote installation. There really isn't any installation manual labor required from people. I mean, it's a 5 minute
Yes.
process to deploy the device. Plus, the big obstacle that you figured out beforehand is you want to be able to put it in remote areas and out on big farms. And one of the negatives right now is that all of this activity has previously been done, feet on the ground, people walking, or maybe an aerial drone, but it's still a very manual process.
Yes.
So you're automating all of that and not making them go out to clean out the bucket or, make sure that that is operating properly. So just kudos to you for thinking ahead of time. What are the obstacles? And let's just go ahead and tackle all of that. Well, you have a device with you for those of us that are watching on YouTube. You can show it
Yes.
to us so we can see what that looks like. And maybe for those that are listening, well, if you are listening, you might want to jump over to YouTube at some point to see this cool device. But if you are listening, Oz is going to describe it for us as he shows it.
Yes, so this is the device, the Mark III. So basically, we have a pole that we are deploying this device above the crop. This is the acoustic distrometer that we spoke about. And this is the way that we are measuring, listening to the rain and converting the sound to a rainfall amount. Here we have a spectrometer. Spectrometer, basically, we are collecting and measuring the reflecting light from the plants and the short wave and the long wave. The short wave that coming directly from the sun, we are collecting this and we are measuring it, but also the long wave that we are getting directly from the sky. So we are measuring the total energy that coming to the earth from the sky and from the sun.
And that's going to impact your growth projections, right? For when things need to be harvested, how fast the plants might be growing, with the spectrometer sensing the amount of light and what kind of light
Yes.
is
And
coming to the plants.
yes, and because, as I mentioned earlier, that we developed this device specifically for collecting information for plants, so we also have a very unique capability to measure only the PAR. It's the photosynthetical active radiation. So it's only the light wave, the frequencies that relevant to photosynthesis. So we can know if the environment or the condition for photosynthesis were better in this field compared to a different field. We can measure it with our device. And but also we are collecting the lights that reflecting back from the plants. The
Okay.
meaning is that, and once we are collecting this information, we can translate this information to a growth of a plant. It's called the NDVI, or the chlorophyll index. How green is the plant? What is
Yeah.
the density of chlorophyll that you have in the leaf? So we can measure it. It's two very important measurement that we have, because if we can expect what should be the growth of a plant in a specific time and physiological stage in an area, and we can see some deviation from what we expected to see, so we know that we have a problem. The same thing we are doing with the chlorophyll index. We know exactly what is the health status of the plant. And also we have we have a camera that taking the pictures of the plant once a day. We have a sensor suite here that can basically collecting all the weather information like temperature, humidity, and we are collecting more than 30 different measurements that relevant for plants.
Okay.
And we once we have this data, we are analyzing this data and providing insight to our customers. One of the key values that we are providing is the irrigation advice. How much you need to irrigate according to the condition that you have right now in the field, with these specific plants, with this specific size, with this type of a crop, how much you need to irrigate. This is what we have all the instrument in this device to evaluate the evapotranspiration in a very good way. But also we are using the NDVI from the spectrometer to identify the size of the crop. And then we can know exactly, because a baby corn and a mature corn are not using the same and not evaporating the same. But by collecting those a few data points, we can provide a very accurate and good recommendation or advice for irrigation.
Wow. And so you're actually with the camera, you're taking that picture once a day, and then that goes along with all the data points you're collecting for each one. You talk about big data. We talk about
Yeah,
having data analyzed. You have so much data where you can be very, very accurate on your projections, and you actually, with the camera, know what's happening there in the field. And
yes.
so how do you I saw on the device, the top of it, I just wanted to explain too, the top of it that senses the rain. It's like a flat top, a kind of
Like a
slight
drum.
top. So there's a little bit of a a space there. It's not like it's just a couple raindrops. You're getting, I don't know how big that is, maybe 12 inches across on the top, where you're getting a little bit, and you can really be able to tell, like you said, what type of rain. I was trying to visualize in my brain when you talked about it, how that would happen. But then I saw it almost looks like a little disc on top,
Yes,
on top, to be able to get a sense across a short span of space. I just think it's really cool because the other thing that I just learned, Oz, and maybe some of our listeners learned, I didn't realize there were certain spectrums of light that are better for photosynthesis.
yes,
I
yes.
Yeah, and that you can sense that. So it's not just any light, it's the specific light that is going to help the plants grow best.
Exactly. The
Wow.
specific frequency that the plants can utilize and can use. Because,
Yeah.
and this is what important. And this is what we are measuring. One of our measurement is this one.
Yeah.
Um, but also the fact that we are measuring all the energy that coming to help to the plants, and energy that we are losing, we can understand the net radiation that the plant
Right.
is experience. And by using the net radiation, it's a key driver for evapotranspiration.
Okay.
Evapotranspiration is transpiration from plants and evaporation from the soil. All the water that the plants are losing, the plants and the soil, this is what we need to bring back. So this is what we are providing our customers, a very accurate measurement of how much water they need to bring back to the plants, because we can calculate what the plants and the soil are losing. So
Yeah. And irrigation is always such, like you said, it's a really important variable that if you don't get it right, if too much water, too little water, and you're just simply giving the analytics for good decision making, very accurate decision making.
Yes, I think that in general, our philosophy is to provide the farmers the tools, the information tools to make an informed decision, a smart decision.
Yeah,
We are not trying to replace the farmer. I don't think this is it's not our goal.
right,
And the experience of the farmer is something that we appreciate a lot, but we want to equip or to empower the farmer with very strong tools that he can make better decision upon his experience and his knowledge. And I think
right.
this is what we are trying to do with our customers. And you are right, to irrigate properly is something that first of all you can increase the yield if you will irrigate properly, if you will provide the water at the right time and in the right amount. And the tricky part it's a double-edged sword that if you are irrigating too low, you can lose, you can damage your production of
Uh,
plants.
Go
So
the other way. Yeah.
yes. So if you want to provide irrigation advice, it have to be with a very reliable tool that the farmers can see and can understand that this is the right recommendation and he can trust the recommendation. And I think this is something that is very difficult to do, but this is why we invested a lot in developing this hardware to make sure that the data that we are collecting is the most accurate that we can provide, and the advice that we are providing is the best advice that we can provide.
Yeah, and I can see that seasoned farmer that has before used his intuition and experience to make the decisions about how the soil was going to be modified, either, add nutrients or whatever might be needed, and as well as irrigation. Now that intuitive approach, you're actually putting that into a systematized approach. I mean, you can kind of take that and with your AI, train it to make decisions like the farmer did, and he can look at the data and make the decisions. So that's really exciting. What about the soil health part? We haven't talked very much about that.
So the soil health is it's a big topic today
Yes.
in the last few years. In the past, we used to look on the soil as something that is not alive, but soil it's a living thing, right? It's like we have a lot of microorganisms and
Biome.
it's a very big and diverse world. What that we are doing regarding to the soil, it's basically measuring the soil moisture and eventually to use data. The best way to use data in the most efficient way is an holistic way. Is to connect multiple data points, and one of them is the soil moisture. So if we can evaluate what is the amount of water that the plant and the soil are losing, and we know how much water you have in the soil, and we can track the growth of the crop and the health of the crop, and all the environment conditions, right? So then we have a very clear picture about, okay, what is the current status of the crop? And what do we need to do? We need to add, we need to reduce. We are doing something good. We can see the feedback, we can see the reaction by tracking those plants every day. If it's with the camera and the NDVI, the chlorophyll index, so multiple points that getting together, and we are creating an insight out of it. So this is the portion of the soil, and the soil is a very important part of it. The soil is important part, the environment is very important part, and also the plants. And this is what we are collecting. So
Yeah. Wow. Wow. And I just think also about combining all of that data with the time lapse pictures, the daily pictures that you're taking out in the field. I mean, you have a total view just even better than if you were standing there in the field yourself, really, because you don't have all that data just standing and looking at the field. I remember years ago, I bought this tool at the local lawn and garden store, and it was something that I put into the pot on my house plant that would then, go deep down in the soil because I can only see the very top. And it was telling me, when I should water the plant. And I'm thinking, well, this is a much, much, much more advanced version of something like that. And obviously at a much multiple larger scale, but that's kind of what I went back to. You can only see what you can see, but there's so much else going on underneath the top of the soil. Like you said, do we have good bugs down there? You know, what's the moisture doing? Is the soil aerated, or, I mean, just the measurement that you're able to make there to see what's happening with the moisture. It's just
Yeah,
fascinating.
yeah, and definitely, and the farmer was able to collect all of those data points only with the sense or intuitive way, but he built this trust and these capabilities over multiple years. And what that we are trying to do, that in one season we can collect all the information and provide all the insight that he needs to maximize the learning curve, right? The learning, the amount of learnings or the learnings that you can have in one season. And then we can build a very strong farmers in 1 or 2 seasons because they have data. They don't need to wait 5, 6, 7, 10 seasons to understand what they can understand in one season because we basically collecting all the revenue from information. And we are not missing anything because this is a device that's working for you 24 hours a day, seven days a week, and just
Yeah.
collecting information, providing you the right insights.
Yeah, so the training and getting the next generation of farmers up to speed and able to make good informed decisions, you just shorten that learning curve by multiple years.
Yes, yes, definitely. And I think this is the biggest impact of technology in agriculture.
Yeah.
To shorten this process and also to make sure that we are not losing knowledge because if a farmer with a lot of experience is retiring, all the knowledge is retiring with him, right? We want to document, we want to make sure that this data is accessible and to anyone that will work for this company or a family farm. And also, yes, to shorten in a very extreme way the learning curve and to make sure that we are optimizing every season. We are learning the most that we can out of every season. And we are
Yeah.
making a day-to-day decision, but also a strategic decision. What we
Right.
can do better next season and what works, what didn't work. So,
Right, because now even based on this data at this time of year for a season, here's the decision that was made, and you know what the outcome of that decision is.
yeah.
And then you can, for the next season, be able to make adjustments. And keep improving as you move forward. I love the whole concept, but Oz, and I really appreciate you bringing that to us. Is there anything else that you would like to share with our audience before we go? I know that now you have version 3 of your device, and when you started out, you probably thought we can get this in version 1. Maybe you didn't think you were going to
Yeah.
have a version 3. Everybody who has these great ideas thinks this is what we need to do, but I'm so glad that you iterated to get to version 3, the best that you know how to produce right now. But what do you see happening in the future? I mean,
I think that in the future, I can see that AgTech technologies are going to play a major part in supporting and developing the farming market in general. And hopefully that we see more and more farmers that adapting technologies, irrigation technologies. But for me, the first moment that I started to use technologies was 20 years, almost 20 years ago as an agronomist. I understand that this is the future, and this is where we need to invest our time and effort. And yes, it's still a very traditional industry, but we are seeing a lot of change right now that farmers are willing to try and to adopt technologies. They're seeing the value of those technologies. Most of those farmers are mostly is the big companies that seeing the future and can utilize technologies today. But we are seeing more and more even small and family farms are starting to use technology and to improve. And I think it's pretty exciting time for us in this market. And I don't have a doubt that technology can make everything much more efficient and environmental friendly and also cost effective.
Yeah, and help us use our resources to
Yes,
the best we can, make the best use of our resources. Thank you
definitely.
for being with us, Oz, and to our audience. If you enjoyed this interview, send us some comments, and we would love for you to connect with Oz. Links to his company will be in our show notes. Until next time, I'm Pam Leinmiller.
Thanks for listening to Future Foodcast. Future Foodcast is powered by Farm to Plate, the leading food blockchain platform. Subscribe on YouTube or wherever you listen to podcasts to stay up to date with the very latest innovations in the food industry.